I'm going to start by asking Adrian the impossible question. And that is, actually, no, I'll change it to make it slightly more impossible. Adrian, which is your favourite building, tall building, sorry, in the world, which you have not been involved in?
Well, I was asked that question at noon, and I answered it by saying the John Hancock Center. But because I divulged that I actually worked on it a little bit, theoretically I couldn't answer it that way. But since I didn't do any design on the building, I'll still say the Hancock Center.
Do we have questions from the audience, please?
Yeah, I have a question for, I guess, anyone. My name is Tyler Taylor. I'm a student here at IIT. And I'm really fascinated by the idea of carrying out projects on this scale where one project can significantly changes the dynamic of a whole area of a city or even a whole city. And I guess my question was, we see a lot of like things on Discovery Channel or in popular science about designing giant multi-use superstructures for like almost like the self-contained cities, like Bertrand Goldberg or Buckminster Fuller's dream. And I was wondering if there's any kind of serious thought about that. If there's like because obviously you guys are the experts, if that's something that anyone is actually thinking about doing at present.
Who were you asking that question to? Any of the panel? Whoever feels brave enough to answer it.
I'll take a stab. One of the reasons to do a super tall building is to create a reason to sell the land around it and make your profit on that surrounding context. Because typically, super tall buildings over 400 or 500 meters are very difficult to design and construct and make money on, especially for a private developer, because of the cost of construction, the time it takes to build a building. His money is out of circulation during that time. And so usually it's for other reasons than making lots of money. In the case of Burj Khalifa, though, the developer Emaar had the idea that they would do Burj Khalifa as the centerpiece for a large development around it. And they ended up making a lot of money on the property around the tower, very little on the tower itself, as it probably turned out, because of the economic cycles. But you can see it in Chicago also, how when Hancock was built, there was nothing over 20 stories around it. Now look at it. There are 60, 70, and 80-story buildings all around it. And it is a magnet for development around it. The same thing exists with Sears Tower, which was, when it was built, there were only 18-story buildings around it. So I think that tall buildings are often a catalyst for a much larger scale development. They also encourage a higher level of public access and public transit, which begins to which begins to create its own sense of improved density around those areas.
I think there are a number of issues related to cities which are preoccupying us. It's about transport, water, power, all these aspects which affect the sustainability of cities. And people query the point of towers. Well, towers can actually contribute, I think, but they need to have a mixture of uses to make them work. We only had 2 on our tower, but I can see the logic of having a kind of vertical city, really, which is on a transportation node in the right location for all the other urban planning reasons. But I think it's wrong to think of a single-use building now where you could have 10,000 people all arriving at the same time and leaving at the same time. It could cause chaos in the city. So I think that's where the multi-use building starts to make sense.
Okay, thank you. Another question up at the top?
Tom McCool with Turner International. Question to Michael Kwok on the exoskeletal frame. What was the method of erection? Is that all welded or is it mechanical?
Yeah, the diagrid members are basically steel tubes, so they are actually fabricated on site, on off-site in a fabrication center in a section of his 3-story. This 3-story section are actually transported to sites using lorries, and once it got to the site, they are actually welded in pairs in a V-shape form, and they are lifted to the position, and there was site weld to be done to connect the section to the others. So it is partially fabricated off-site and partially installed on-site.
Question here in the middle.
Hi, I'm Christelle Calderon, and I'm a student here at IIT. And I have a question addressed to most of you. And this is related to the parametric design and how we use computer right now to help our design. And my question is, which advice would you give to a student to which computer tool should we use, or maybe tell us a little bit about your experience of how sometimes your design is constrained by the computer, or how sometimes it actually develops your idea in a very good way.
Maybe we could address that to John first.
Sure. It's a bit of a complicated question, actually. In terms of Frank's process and how we use the computer, it boils down to the right tool for the right project. Frank's process always begins with the physical model. That information is then taken into the computer and software. There's a couple of different softwares that we use depending on the complexity and the geometries that we're after. For our process and for essentially all of the buildings, once we go beyond the design phase, everything is in digital projects. Gehry Technologies is our sister company and is really devoted to that. So if you're really interested into that, that would be a great place to start. Everything is, once we have a basic direction through the digital project process, the design is essentially set. We're not going back too much and having the computer drive the big picture at that point. We're using to develop the information further into a way that, in a means that can be documented properly and fabricated from. So it's kind of a bigger picture on how we do it. It's not solely related to using the computer to develop the shapes and the forms. It's really driven from a physical process. It is refined, though, through the computer.
I think that's a good answer. Should we move on to another? Was there another question up at the top here?
My name's Arjun. Oh, jeez, that's all. My name's Arjun Magoon. I'm a fourth-year architecture student at IIT, and I have a question specifically for Mr. Wilkinson on the last project we saw, and that was that you said that you started off with a double-skin facade, and then cost analysis didn't warrant it, so you moved down to single skin. And then I was wondering if you could elaborate on any solar or thermal systems that went into that building specifically.
Yes, I'm not really able to go into the detail, but conceptually, we saw it as a double skin facade, particularly on the areas on 2 of the 3 sides. It wasn't absolutely necessary on the 3rd side because it didn't pick up so much sun. But obviously there's a cost to pay for that. There's a saving to be made, energy saving, and our clients didn't feel, at the time when they were perhaps adding up the total cost of the building, they were concerned about costs, so they cut it back. The alternative to double skin, when we looked at all the different sorts, we ended up with a ventilated double skin, I think. The alternative is to go for intelligent glass, which was our only option. So there are, in China, you'll see a lot of quite dark glass buildings, and that's because they kind of blot out the sun as much as they can, but they also blot out the light, which means that you end up putting more artificial light in the building and so on. So it's a complicated process. It's a complicated problem and process. We steered the best course we could, and there were some samples, I think, on the images we showed of big areas of glazing going up as samples to benchmark the building. And we ended up with something that was a little bit darker than we wanted, but provided a reasonable environmental protection.
Question here in the middle.
Hi, my name is Elaine Ryans. I'm an architectural designer, work here in Chicago. I actually work for Adrian Smith, so this time I'll let him off the hook. I have actually 2 questions, one for John and one for Chris. So should I just spell it out all at once, or should I go one by one?
Let's try them both at once.
Okay. For New York by Gehry, John, you mentioned that the floor layout varies from floor to floor. And I'm wondering, could you elaborate a little bit more on how you collaborate or coordinate that, and what type of digital tools you use for that? And for Chris, you mentioned that you want to achieve this clean, elegant, and simple facade. I'm wondering, all those facade panels you're using, are they some sort of hot bend glass? From the picture I'm seeing here, it's not facets, right? Are those smooth bent glass? And I'm wondering, could you give us an idea how you achieve that without client budget kind of give you a hard time on the budget?
Should we take John's first? Should we take John's question first, then Chris?
Okay, that's fine. So on the tower, we had a complete 3D model, which was in digital project software. From that meaning complete, essentially everything was contained in the model, including the exterior surfaces, the structure, the mechanical systems, including even to the gypboard partitions. In terms of coordinating all of the risers and all the spaces, everything was fairly tightly coordinated and close. We were looking for essentially every inch that we could find. So using that tool really helped us to get there. In terms of, I think your original question was in the slab edge. The slab edge was driven from the curtain wall units themselves. So it was outside working back towards the inside. That information was essentially generated through the collaboration with Permis de Lisa, as well as some of the detailing, the fire safing detailing between the slab edge and the backside of the curtain wall system itself and the smoke seals that are required by code. That information then, once we were able to have the curtain wall units set in the 3D model, there was just simply offset geometries back into the building itself, which set the slab edge. and then the columns and the rest of the elements that were embedded into the slab. But everything is generated from the three-dimensional model. From the three-dimensional model, two-dimensional drawings were also supplied. It was both products in the end were our contract documents.
Chris, just to reiterate, are those facade panels bent or faceted?
The facade panels are all flat glass, and they're a unitized system, 4 meters by 1.5 meters, and our main aim was to get the maximum repetition in order to bring the cost down. There were, on the corners, the glass panels are half the width to deal with the tighter radius. And there were some special makeup panels, but relatively few. So they're all rectangular glass panels, 4.4 by 1.5. I'd just like to say, though, that this was our concept for this building, and we've never done another building like it, probably unlikely to, because we treat each project very differently. So on many projects, I would be arguing to have quite complex variations in the facade for architectural reasons and for programmatic reasons. But here, we came to the conclusion that we wanted this transparent facade with the expression of the exoskeletal frame behind, and to keep it as clean as possible.
Okay, I'd like to finish with a question, if I may, on Chair's prerogative for Michael at the end. My perception of super tall structures is that they're tending more towards core and outrigger systems. So my question is, how high do you think you could have gone with Guangzhou IFC or a similar building without putting in an outrigger system? How efficient is that system in terms of taking it, 600, 700, 800 and above?
Actually, with exoskeleton diagram, it can actually take the building very, very tall. Actually, the external tube is a very effective system. This is exactly what outrigger is trying to do, is to get the forces to the outside of the building, to mobilize the columns at the perimeter. The exoskeleton diagram naturally done that without the use of outrigger. So in a way, that system actually is much more effective than an outrigger system. The only issue is maybe for certain client, they do not like the cross. In Chinese, we previously, in the past, we do have that kind of problem. But this project, the client to see these are diamonds rather than crosses. So they really like this particular configuration. But I would say the diagram system can actually take the building quite tall with a much more efficiency higher than outriggers.
So in the world's tallest building, or perhaps even a mile-high tower, where maybe cost is not the prime aspect here, on prime consideration, do you think that the diagrid system is the most efficient system for super tall?
You definitely need to have certain form of triangulation at the exterior envelope in order to achieve that kind of height. Whether it's a diagram, whether it's a mega frame with braces, I think you do need that kind of structure to take you to that kind of heights.